Hello again. Maybe this will be the last video for chapter 11. I want to jump directly to problem 24 because it's connected to problem 16. In problem 24, we're asked to use the information from exercise 16 to estimate sine of 38 degrees, corrected 5 decimal places. So first of all, let's take a look at sine 38 degrees, which is 30 degrees plus 8 degrees. So this is pi over 6 plus 8 degrees change into radians is 8 times pi over 180. And we simplify that into 2 by 4, yes, 2 pi over 45. So 2 pi over 45. We continue here. And the least common denominator will be 90. So we need a 15 and we need a 2. 15 plus 4, so it's 19 pi over 90. Okay. So also remember that we had sine x was determined with polynomial t4 plus a remainder corresponding to the Taylor polynomial degree 4. I'm not going to copy T4 here, but if you remember, we got where was this? I'm just looking to see where. So this was the, we did not, oh, we did, okay, he's right there, right in front of me. Okay, perfect. So this will equal T4 and plus 0.000269 on the interval 0 pi over 3. Okay, so then now I'm on page 9. Okay, so then a sine of 38 degrees will be 1/2. Let me bring the Taylor polynomial so we can have it here. We have it, we need it here. Okay, so I'm gonna do this. Okay, so it's 1/2 plus the square root of 3 over 2 times x minus pi over 6. It's that 2 pi over 45 minus 1/4 2 pi over 45 power 2 squared minus the square root of 3 over 12 2 pi over 45 to the third plus 1 over 48 2 pi over 45 to power 4, which is approximately 0.61566. Okay, that's, I calculated that in order to cut back on time. Okay, so now finally we can also determine the error. Let me have these in the correct order. Yes, I do. So then R4 for 19 pi over 90 is less than or equal to 1 over 120, which is the 5 factorial, times 2 pi over 45 to the 5th power. And I calculated that to 0.303044. So that's the error in our approximation of sine 38 degrees using the Taylor polynomial with degree 4. Okay, we are free to move on to 21 now. on page 818. And here we have f of x equals x sine x, a equals 0, n equals 4 again, -1 less than or equal to x less than or equal to 1. So because a is 0, we can already write this. Good, so let's find f of 0, which is 0, f prime of x, which is sine x plus x cosine x, and then f prime of 0 is 0. The second derivative, cosine x plus x times negative sine x equals 2 cosine x minus x sine x. So the second derivative at 0 is 2. Moving on to the third derivative, and that is -2 sine x minus x cosine x, and that is -3 sine x minus x cosine x. The third derivative at 0 is 0. Let's move on to the fourth derivative now. I'm on page 10. Page 10. So the fourth derivative, -3 cosine x minus cosine x plus x sine x equals -4 cosine x plus x sine x. And the fourth derivative at 0 is -4. Okay, so that we have all the derivatives and their values. And now let's write T4. So that will be 2 over 2 factorial x squared minus 4 over 4 factorial x to the fourth. And this is simply x squared minus 1/6 x to the fourth power. Now that was part A. In part B, we want to find the fifth derivative, S4 sine x plus x cosine x. So this is 5 sine x plus x cosine x. And R4 will be less than or equal to m divided by 5 factorial times x to the fifth, but that is 1 to the fifth power. So the upper bound m, notice that the maximum that this can have, maximum value, is really 5. So this will be 5 divided by 5 factorial. So I calculated, did I calculate? Yes, I did calculate this. So I got 0.00416 repeating decimal. And yes, in part C, we're also asked to graph. So to graph R4, remember we have the absolute value of x sine x minus x squared plus 1/6 x to the fourth in absolute value. Okay, and I think I entered that too. I just need to find it. Okay, it was I lied. Check your result by graphing. I did not. So I did not do that. I did not put in x sine x minus, nope, I did not do it. Okay, so I'm going to clear this one, de-highlight that. I'm going to use the absolute value, and the absolute value of x sine x, and then minus x squared, but plus in parentheses 1 divided by 6 multiplied by x to the fourth. x to the power 4. Okay, so I have that in. Now I need a viewing window. The viewing window has to be between -1 and 1 with a scale of 0.2. And how high? I'm going to put 0.01. Okay, I'm going to check at the endpoints at -1 and +1. So second and enter, -1 and 1. No, I didn't mean that. -1 enter and 1 enter. So 0.008 and 0.008. I'm checking my function one more time. X sine x, yes, that's correct. Minus x squared plus 1/6 x to the 4th. So can I improve on this? So everything appears to be okay. Let me look again. Just check the function. Yeah, between -1 and 1, that's correct. Yep. Everything we entered, it's minus here and plus here, correct? Okay, I'm checking. So 0.008 and 0.008. So what I got here is less than that. I cannot further improve. So that was correct. That was 5. That was 5 factorial. I'm checking my numbers again. So yes, it was 1/24 because we simplified. Let me check this number again just to make sure. So 1 divided by 24. Ah! Well done, Monica, well done. That's why. Sorry about that. So 0.08, 0.0416, not 00. Careful. So yes, an improvement. 0.008 versus 0.04, of course, better. Good. Awesome. Moving on. I'm glad I caught that. Okay, so we have to look at 2 more questions. So number 26, same page, 818. In 26, they're giving us natural log of 1 plus x, and that's our function, f of x. And they are saying how many terms of the Maclaurin series, which means a equals 0, do you need to use to estimate? To estimate natural log of 1.4 to within 0.001. So that's the question. So how many, again, how many terms? So basically, how much is n? Okay. So please remember from in this chapter we learned that a natural log 1 plus x can be rewritten. So in order to write this, so this is Rn of x, of course, less than or equal to 0.001. So natural log of 1 plus x, n equals 1 to infinity, -1 to n minus 1, x to the nth power over n. So this translates into x minus x over 2, x squared over 2 plus x to the 3rd over 3 minus x to the 4th over 4 plus ... And we are looking at, remember, natural log of 1.4, which is natural log of 1 plus 0.4. So x in our situation, by comparison, is 0.4. Okay, so because this is an alternating series, we can use Rn of x less than or equal to the next discarded term. And this is 0.001 that is given in the problem. So when we look at these numbers, so from here, I'm just going to jump over this so I don't have to write it again. So this is 0.4 minus 0.4 squared over 2 plus 0.4 to the third over 3 minus 0.4 to the fourth over 4 and plus 0.4 to the fifth over 5 minus 0.4 to the sixth over 6 and so on and so forth. And what I did next was I put in all these numbers in the graphing calculator. So this is 0.4. Let me use a different color here. So this was 0.4, but this calculation is 0.08. This calculation, this whole thing, this piece is 0.02133. This piece is 0.0064. This piece is 0.002048. And this piece is 0.00068. So we are going to keep the first 5 non-zero terms. So keep first 5 non-zero terms. So n equals 5. This is already below 0.001. That's where we stopped at before. Okay, and here the last problem, 29, page 12. In 29, they're giving us arc tangent x as being approximately, of course, x minus x to the third over 3 plus x to the fifth over 5. So use the alternating series estimation theorem or Taylor's inequality to estimate the range of values of x for which the given approximation is accurate to within, so the error, so Rn has to be less than or equal to 0.05. Okay, so find x this time. Find the range for x. Good, so the error has to be less than or equal to 0.05. So as we know from the alternated series, so this is less than or equal to the first, less than or equal to the first discarded term. But in this particular situation, because this is term 1, 2, 3, 4, 5, so this must be n equals, so the sixth one, right, it will be 0. So then we have to move on to the next one, non-zero. So this will be B7. So this is negative x to the 7th divided by 7. And this has to be less than or equal to 0.05. Of course, we are discussing absolute value. So when we solve this inequality as x to the 7th less than or equal to, in absolute value, less than or equal to 7 times 0.05, and because we are talking about positive terms, we have x to the 7th less than or equal to 0.35, and we take the 7th root from both sides, because we are talking about positive terms. When you take the 7th root of 0.35, you will get approximately 0.861. So then x has to be between negative 0.861 and positive 0.861. Thank you. I hope this helps.